Hello everyone, welcome back to Comment Made Easy, and I hope you all are doing very well. Before we begin, let me remind my dear students that the contents of this channel are only to supplement your knowledge, not to replace the regular online and offline classes in your institution. So please attend your classes and do not miss them. Also, if you like our contents, please subscribe to our YouTube channel, like the videos, and share these videos with your friends, with your batchmates, with your juniors. Also, if you are a teacher, then with your students. Please follow our Facebook page, and the link will be given in the description. In our last video, we learned non-probability sampling. Today we shall talk about simple random sampling, which is obviously one kind of probability sampling. So the question is, what is probability sampling? It is that kind of sampling where individual sampling unit has equal and known chance of being selected. So that is why probability sampling is considered superior to non-probability sampling, because it follows or obeys the laws of probability. It is based on concept of random selection, and that is why it is also known as random sampling or chance sampling. So simple random sampling. This is the most common method and the simplest method. Each member of the population, that means each sampling unit in the population, has an equal chance of being chosen. It guarantees that the sample chosen is representative of the population, better suited for small and homogeneous population. So if a given population is not very large, okay, so this is small and also homogeneous, that means the certain characteristics in those people in the given population are almost similar, there is not much variation, so in that case we can call it a homogeneous population. So in such small and homogeneous population, simple random sampling is the best technique for sampling. And whenever we take a sample using simple random sampling, it is most likely a true representative of the given population. Now complete population list, that is sampling frame, must be available. So we need to know the sampling frame, which is basically the enlisting of all the members in the given population. So that means in a given population, whatever number of people are there, we must have identification for example their names or any identification code that is present. So all of them must have certain kind of identification number or any assigned number. So this is known as sampling frame. First, all sampling units are assigned with numbers. So this is the first thing that we have to do. We have to give the numbers to individuals in the study population. For example, we can start with 1. Maybe we have 1000 people in a given village. So the first person will be given a number 1, the second person number 2, like this. So when we are reaching the 1000th person, he will be given the 1000th number. So that means each person in that village will have one unique number. Sample can be selected by random number table or lottery method. So maybe out of this 1000 uh, people in the village, we need to select 100 people as a sample. So that means we need to select 100 numbers from this 1000 numbers, and it can be done by random number table or lottery method, which we shall discuss next. The disadvantage is whenever the sample size is low, it may not actually be a true representative of the population. Also, if the given population is heterogeneous, that means they are not homogeneous, even in that case the sample we draw may not be true representative of the population. So this is an example. We have about maybe 20-25 people here, and from them I need to select about 10 people as my sample. So this is my population, and from them randomly 10 people have been selected, so that is my sample. So let us try to understand with an example. Suppose there are 200 students in the class and we need to conduct a short survey on them. We decide that a sample of 20 students should be sufficient for the purpose. So what informations are we getting here? Number one, the population size is 200 and the sample is 20. So we have to select 20 students from a population of 200 students. So first thing we have to do is assign a number from 001 to 200. So If there are 200 students in the class, maybe we can use their attendance register and they will be given roll numbers, roll number 1 to roll number 200. So individual students will have unique code roll numbers, and these roll numbers can be used to select the samples. Next, we can use a random number table or lottery method to select 20 unique roll numbers from this list of 200 roll numbers. So let us learn how. So this is what a random number table looks like. So this is not the only random number table. You can find in internet or different books where these numbers are obviously different. So there will be various um, form of random number tables where the numbers or digits are different, but more or less the purpose is same. So how to take a sample of 20 students from a class of 200 students, that is my population, using the random number table? So that is the question. So in this particular video we are going to talk about how to use a random number table for simple random sampling. So n, that is the population size, is 200. So how many digits are there in this number 200? 3 digits. So 2, 0 and 0. This is very important. And the sample size is 20. Only the random numbers with last 3 digit value less than 200 or equal to 200 will be considered. Okay, so for example, this one 21160, this number, we can see the last 3 digits are 160, which is obviously less than or equal to 200. So that is why we can consider this number if it is needed. Whereas the next number 50404, the last 3 digits are 404, which is obviously bigger than 200. So that is why in any case we are not going to consider this particular number. Now remember, in this example I have taken the last 3 digits. You can also take the first 3 digits if you want. So there is no such rule that you only have to take the last 3 digits or last 2 digits, depending on how many digits are there in the population size. So you can also take the first 3 digits if you want. So in this example we have taken the last 3 digits. Next we have to decide in which direction we are going to go to select our numbers. So here I have first taken upwards direction, followed by left side, then downwards direction, and then towards the right side. First thing that we have to do is we have to close our eyes and put a dot on anywhere on this random number table. Suppose we have put our dot here, somewhere here. If the dot is exactly over any number, then we shall select that number. If it is in between two adjacent numbers, then we can select the closest number. For this example, we have selected this 96334, this particular number. Next thing that we have to decide is in which direction we shall go. First we shall go upwards, then towards the left side, then towards the downside and rightwards. So first upwards, so this particular column, towards the left side, that particular row, downwards and towards the right. When we go in particular direction, of course we shall look for the last 3 digits of every number. So as you can see, when you are going upwards, I have selected these 3 numbers where the last 3 digits are less than 200. If you remember, I mentioned here the last 3 digits should be less than 200 or equal to 200, and that number will be considered. So we shall note this. So first one is 186, then 39, 039 means 39, and 184. So in this row from here to here, we do not have any other number where the last 3 digits value is 200 or less than 200. Now going towards the left side, 000, but 0 is not included. We have number 1 to 200. So that is why number 0 is not included. That is why we are ignoring this number. Then we have 136 and 66. Then we are going downwards, so 94 and 143, and then we are going towards the right side, so 178 and 50. So now we have 9 numbers. So the first 9 samples have been selected. So as you can see, after this procedure only 9 samples have been selected, and we still need 11 more samples because the sample size is 20. So what we do is we close our eyes and put our dot blindly on the random number table, and we continue this procedure again. So similarly, suppose next time the dot was somewhere over here and this number is selected. We do the same thing. We go upwards and we select these two numbers 176 and 46. Then we go towards the left side, so 112, and downwards 140, 110, 178 and 85. So we note down these numbers. So now we have selected 7 more numbers. So 7, we had 9 earlier and we have selected 7 more now. So now we have 16 samples. We still need 4 more samples. So that is why we are going to continue this again. Another dot was blindly put on this random number table, and from that number we are going upwards. So 48 is selected. Then we are going towards the left side, 129, 68 and 19. So we have our 4 samples. We do not need to go downwards or towards the right side because the total number of sample, that is 20, is already achieved. So like this, using this random number table, we can select 20 unique samples, or 20 samples having unique numbers or identification code. So that means we can from the attendance register select all the students having these roll numbers. So 186 roll number 39, 184, 136, like this. So these 20 students will be the sample for my study. There is another way we can select students, for example, lottery method. First, we assign numbers to each members of the population or sampling frame. This is I already discussed. So we have the attendance register and we have the roll numbers of the student from 1 to 200. So that is my sampling frame. Then we make small sheets of papers for each unit in the population, which are folded and then mixed together. So we can take identical paper sheets, and on every sheet we write every roll number. So starting from 1 to 200, we fold them so that we cannot see the numbers. Then we can mix them in any kind of bowl or bucket or box, whatever, and then we can randomly pick up 20 such paper sheets where we shall get 20 different roll numbers, and these 20 roll numbers will be the sample for my study. So this is lottery method. So this is how it is done. So for example, if you want to select 20 subjects randomly from a population of 200, you can write their names or even roll numbers if it is a population of students, fold them up, mix them thoroughly, and then pick 20. So this is exactly what I discussed earlier. There is also another option like online random number generator, which is very common in the internet. You can search with online random number generator and you shall get a lot of options, and they're very easy to use. They ask the lower limit and the upper limit. So if we have 100 students, that is my population, then we have to write 1 because that is the lowest number, and the highest number is 100. So 1 to 100. 0 is not considered, obviously, because no one can be 0. And then we have to click this button, generate. Okay, so when I click it, I get the number 30. So roll number 33 is my first sample, and we have to click on this generate button again and again. When I click it next time, this 33 number will be changed to something else, say 45. So roll number 45 will be my next sample. So like this, I can click it as many times as I want. Suppose if I need 10 samples from this 100 students, then I have to click it 10 times, and every time I shall get different numbers here. So that is the roll number of the students that I have to select for my sample. In case if I get a number which is repeated, we can ignore that number and press it once again. Random sampling can be with or without replacement. So in simple random sampling with replacement, the selected unit is replaced back to the population and again has a chance of getting selected. Whereas in simple random sampling without replacement, which is the usual method in medical research because we follow the without replacement sampling method, and the selected unit is not put back in the population, and hence the population size decreases by 1 at each selection. So let me give you an example. Suppose we have 10 numbers in a given box, and we have to randomly select any two numbers. So the population size is 10 and the sample size is 2. Let us learn the simple random sampling with replacement. So suppose we need to randomly select two numbers between 1 and 10. So that is what I said here. Suppose the first number we pick is 3. So we pick this one first. So that is my first number, 3. The probability of 3 or any number, the first number being selected is 1 by 10. Why? Because we have 10 options and from that we are selecting only one number. So the probability is 1 by 10. Next, what we have to do is we have to return this ball, which is number 3, to this box, so that right now we still have 10 options from which we can select the second number. Then we select the second number, and suppose it is number 7. So the first number is 3, we return it again to the box, and the second number is 7. When we are selecting the second number, it is still having the same probability of 1 by 10 because there are 10 options and from which I am selecting only one. So that is why we can say that one does not affect the outcome of other. So when the first number is selected, since it is returned to this box, it does not alter the chance or probability of the second number being selected. So the probability of any two numbers being selected is following the law of probabilities 1 by 10 into 1 by 10, that is 1 by 100, that is 1%. So in SRS with replacement, after selecting any particular number, we return it to the box so that the probability of being selected for the next number is also same as the first number. What about SRS without replacement? So same thing, suppose the first number that is selected is 3, and since this is the first number, so we selected any particular number out of 10 options, so the probability of being selected was 1 by 10. Now we do not return this number 3. So when we select this particular ball with number 3 written on it, we take it out and we do not return it to this box. So now I have 9 other options, and from which I shall select my second number or second ball. When I am selecting the second number, suppose the number that is being selected is number 7, but the probability of number 7 being selected was 1 by 9 because since I have taken off this particular ball and there are only 9 options left, so the probability of being selected here was 1 by 9. So in other words, selection of one item affects the outcome of the other, because when one item is selected, the total options is reduced or decreased, and the probability of any two numbers being selected is 1 by 10 into 1 by 9, that is 1 by 90, which is equal to 1.11%. The probability of two numbers being selected when we are doing sampling without replacement is 1.11%, while it is 1% when we are doing sampling with replacement. So this difference of 0.11% between these two methods may not be very prominent, but you have to understand that we had only a population size of 10 and we had only selected two samples. But if we could take a large number of sample from a large number of population, the difference between the probabilities of being selected would be much large and much prominent. So that is why it is ideal to go for sampling with replacement, but in regular research work in medical science it is quite difficult to go with replacement method, and that is why you go for random sampling or any sampling without replacement method. So in today's video we learned about simple random sampling, how to conduct simple random sampling using random number tables or lottery method or even random number generator calculator that is available on internet. And then we also discussed how to do sampling with replacement or without replacement, and what is the difference between them. With this, we conclude today's session. If you like the video, please subscribe to our channel and share this video with your batchmates, juniors, and friends. We also have our Facebook page that you can follow. The link is given in the description. Take care, and we shall see you in our next video.